G'day everyone, welcome back to the lab. Here we go. Now what we're going to do today is we are going to look at the half cells reactivity series, and in particular today we are going to be looking at these combinations of half cells. And the half cells that we're going to be looking at today is the iron with the iodine, and we're going to be using a carbon electrode on those two. We've got the iron combination, the iron 3 and the iron 2 nitrate solutions with the copper nitrate and the copper electrode. Of course, that's the carbon electrode. Carbon electrode again here, but this time we're going to be using the zinc nitrate solution with the zinc electrode. The fourth combination is the iodine, 0.1 molar, once again carbon electrode, with the copper 2 nitrate solution, copper electrode. Once again, the iodine with the carbon electrode, the zinc with the zinc electrode, copper with the copper electrode, and the zinc nitrate with the zinc electrodes. And these are the solutions here, and that's the iodine solution is a combination of the iodine plus the potassium iodide, the 50-50, one's a 0.5 molar, one's 0.1 molar. The next one along is the iron 2 and the iron 3 solutions, that's the iron sulfate and the iron nitrate, 50-50, 0.1 molar. Next one along is the copper nitrate solution, 0.1 molar. And last but not least, the zinc nitrate 0.1 molar solution. So they're all pretty distinct there. One's clear, blue, orangey, and of course a dark colour. The electrodes that we're going to be using today is a carbon, copper electrode. You know, it's important that when we use the copper electrode and the zinc electrode that they are thoroughly cleaned. So that make sure that they're back to bare metal and there's no oxide built up on them, because that will create a resistance, and that resistance will give us a false reading or a misleading reading. The salt bridges that we're going to be using today are potassium nitrate, filter paper soaked in 1 molar potassium nitrate, and digital voltmeter here. And as you'll be familiar with this by now, the VC students, when we use voltage, okay, it's the center where it says V, and the common, just put that out of the way for a second, where it says common. Black always goes in common. If we measure current, we move it across, but that's it. So what we'll do now is we'll look at the first solutions that we're going to be setting up. And the first one is the iron with the iodine. Okay, so I'm going to pause it there while I set this series up, this half cells up, and then we'll take it further. Okay, here we go. So the two half cell solutions that we're going to be using next is the iron, which is the iron there, with the iodine. That's the iodine there. And like I said, there's the electrodes that we're going to be using, the two carbon electrodes. And let's get ourselves a salt bridge. Okay, now it's important that when you place the salt bridge in there, it doesn't touch the electrodes, because once it touches the electrodes, basically get a short, so we get the ions flowing directly across, not going through the solution. So we'll just separate those a little bit. All right, let's attach our electrodes to the multimeter. Now it's a little bit tricky with these particular electrodes because they're a little bit flopping around all over the place. But anyway, let's see how we go. Now if you get a negative reading, it just means that we've got these wires around the wrong way. So let's see how we go here. Okay, so that looks promising. So at the moment, we're getting about 0.09 of a volt. That's 0.09. Now, I don't know if you can see that. That's in millivolts there. So 3 decimal places to the left. So it's about 0.09 volts with this combination. All right, so what I'll do is I'll just pause it there and I'll get the next combination, which is the iron solution with the copper solution, of course the copper metal electrode. So just bear with me and I'll set that up now. Okay, so I've brought across the copper nitrate solution with the copper electrode, and this is the copper electrode, but it's, like I said earlier, it's very important that any oxide like there has been removed so we don't get a misleading thing. So let's pop that in, connect our alligator clip, and once again, and this is probably the most important part, is that we get a new salt bridge. And place it across, and always keep in mind not to get that salt bridge touching the electrodes. Alright, so here we have our combination, and at the moment it's reading 0.4 volts. I'll just bring that up to you. So that's 0.4 volts. So the iron nitrate, combination iron sulfate, iron nitrate solution with the copper nitrate solution, we are getting 0.39.4. Okay, so I'll pause that and I'll set up the next one. All right, our third half cell combination that we're going to be doing is the iron 2 and the iron 3 with the zinc and the zinc electrode. So here we go. Get ourselves a new salt bridge. Bridge it across the two beakers. Okay, this one's not being very cooperative. Okay, so this one is producing 1.3 volts. That's 1.3. So the iron and the zinc are producing 1.3. I'll pause that now and we'll go on to the next one. Alright fellas, girls, boys, here we have the iodine solution and the copper nitrate solution with the appropriate electrodes placed in place. Now we'll get the salt bridge across these two and let's see what we produce on this one. You're not supposed to touch it, but I can't seem to separate that one. I should be using gloves as well. Okay, spot on. Alright, make sure that the electrodes are not touching the salt bridge. All looking good. And this is producing millivolts here. It's producing 0.3 of a volt. 0.3. So the iodine and the copper nitrate, 0.3 of a volt. Alright, pause it again. Now this combination is the iodine with the zinc and zinc electrode, and of course the carbon electrode there. Alright, hope this doesn't sound too boring. We'll just move across a bit. Can't see the bottom of that. Oh yeah, let's go across a bit more. Okay, make sure nothing's shorting out. New salt bridge. The iodine with the zinc nitrate is producing 1.2 volts, 1.23, 1.2 volts. It's close enough. Okay, now we'll move on to our final one, which is the copper metal with the zinc metal. So the copper to nitrate solution with the zinc nitrate solution. So let's pull these two apart. Remove that one. Bring the copper across. Touch our electrodes. This is very poor practice, so I should be using gloves. Okay, so bring those two across. Alright, make sure nothing's shorting out, new salt bridge, positive reading there, positive reading there. So this is producing 0.92 volts, 0.9 is close enough, so 0.92. And that pretty much concludes this experiment. Now, I'm not going to run through any of the theory with this. This will be with your teacher. But in terms of the experiment, and this is basically it. So we've got our half cells here, and we've run 6 combinations, and we've got 6 different voltages. We should be able to now produce a reactivity series based on those results. Okay, so till next time. Good afternoon.